All right, everybody, and welcome to the Daily Space Weather Show. We've got a coronal mass ejection here popping off in the just past few hours. You can see that over there on the eastern limb. We do have a rising likelihood of large solar flares here as an active region approaches the northwestern limb as well. We'll go over where the largest flares were in the past 24 hours. And there is the full disc view. By the way, I'm your host, Dan, a.k.a. Smash-O-Mash, and thanks for tuning into the Smash News Network, least busted name in news. So these are all 24-hour videos from SDO. We've put together 304 plus 193 angstroms. That is ionized helium and ionized iron, respectively, from the AIA instrument. We also have a lot of filaments on the Earth-facing portion of the solar disk, as well as hanging off the edges, so you might see a few huge plasma crown prominences up there around the northern hemisphere. What's that? You want a closer view? All right, we've got that covered. Pretty sweet, right? So there's a great view of that crown prominence. We call them crown prominences when they're around the polar regions. Otherwise, they're just prominences, but they're ultimately the same thing as plasma filaments. So there you can see another huge prominence around the western limb. And the most likely place for a large solar flare in the coming 24 hours and is going to be this group up here. Because the Earth-facing quiet is expiring as it gets closer and closer to the limb. There's also another huge plasma filament in front of it there. It's this feature right here. And the largest flare of the past 24 hours came from that group down there setting. It was only a C-class event. And we've seen actually kind of a surprisingly low number of solar flares for the past 4, 5, 6 days. Quite a lengthy period here without an M-class flare. There's the southern hemisphere for sake of completeness. And let's take a look at sunspots here for a brief moment. There is the SDO continuum. Yesterday plus today, August 18th and August 19th to date. Looks like no major changes there. Quite stable over the past 24 hours. I don't see any new sunspot groups. I don't see any degradation of sunspot groups. Here's the colorized magnetogram for the same period. And we're going to show volcanoes and earthquakes, but before we do that, take a moment to press that like button. Do yourself a favor. Make sure you get the most comprehensive daily space weather videos and most detailed imagery of the sun you'll find in the known universe on your YouTube subscription feed. That's okay, we can wait. Have you pressed the subscribe button if you're new to the channel? Thanks to our new viewers, by the way. And yeah, it was a big day yesterday. Lots of people tuning in to the channel. So if you want to share the videos with people who have short attention spans or who don't have time to watch our main features, check out the shorts featuring everything from forecasts of hurricane activity to all kinds of close-ups. So thanks to everybody who's tuned in. Thanks to our new subscribers, especially thanks to the Smash team for increasing the probability these videos will continue to exist, remain publicly visible, and free for all to view. So here's the volcano scenario. And I'm finding out at the same time you are here, sort of. Mount Mayon here produced a volcanic ash cloud of unknown size. Bagana here produced a 25,000-foot ash plume over Bougainville Island, part of Papua New Guinea. So that's a significant uptick there at Bagana. Manam on Papua New Guinea. That's exploding as well. 10,000-foot ash plume there, flight level 100. Flight level 150 over Semeru on East Java, Indonesia. Flight level 210 over Popocatépetl, now back on the list. And it's on my bucket list, by the way. Popocatépetl there, the central Mexican volcano there, located just northeast of Mexico City, producing a flight level 210, a 21,000-foot ash plume. Fuego in Guatemala exploding, flight level 170. Nevado de Ruiz exploding, flight level 210. That's located in Colombia, by the way. Sangay and Revenador producing 21,000-foot and 15,000-foot ash plumes, respectively. It's a flight level 210 over Sangay and a flight level 150 over Revenador. Sabancaya, flight level 230. It's exploding in Peru. It's a 23,000-foot ash plume. Not sure about Ubinas. Oh, no volcanic emissions. No volcanic ash emissions from Ubinas in that same nation. Next, looking at earthquakes, and it's been pretty calm here over the past 24 hours. There is a convenient 90-day bar graph for you. Feel free to pause the video on this frame. We're moving on to our 24-hour list from USGS. So we will cite quakes of a 5 or greater magnitude. And do we even have any over the past 24 hours? So some quakes in the U.S. here, but no large ones. The first 5.0 to happen in the past 24 hours was a 5.0 at the Philippines. It was at 18:35 Universal Time yesterday evening. It was also at depth. 115.2 kilometers, the estimated depth of that one. And moving up the list here, it looks like only one 5 magnitude quake over the past 24 hours. It's a bit of an earthquake shortage here at the moment. There were some quakes in the U.S. Drop us a line if you felt a United States earthquake, or if you felt an earthquake anywhere for that matter. And here is the past 24 hours of the closest star, and thanks for stargazing with us. That's 171 angstroms. The house favorite wavelength. And how about a closer view? And there's another 24-hour video from the Solar Dynamics Observatory. We'll also add 131 angstroms here to show some additional detail. Once again, the largest flare that's occurred in the past 24 happened this morning. It was down there in the the southwestern limb right down here. And it was only a C-class intensification. We've been having a shortage of large solar flares. So let's look at some stats here. The 10.7 centimeter radio flux, a radio signal that it comes out of the upper chromosphere and lower corona, sort of the transition region there, above the solar surface and below the solar atmosphere, well, at the bottom of the solar atmosphere. The 10.7 centimeter radio flux now at 150 solar flux units. If you're wondering what a solar flux unit is, it's 10,000 Jansky of radio flux density. Jansky is just a measure of radiation traveling through the near vacuum of space. 151 is the current radio flux number. This depicts a 1-year solar activity there. And if you're wondering if the sun is shutting down, it is still ramping up. We are still like a year out from solar maximum. Notice the upward trend. The upward trend here over the past year. Probably not a double peak solar cycle or anything like that. Just a solar cycle much stronger than solar cycle 24, possibly even stronger than solar cycle 23. And let's take a look at the Space Weather Enthusiast dashboard next. So there's the NOAA forecast for space weather over the next 3 days. No geomagnetic storms, no geomagnetic unrest. Not a lot going on. The coronal hole high-speed stream has subsided. We'll talk about that here in a moment. That is NOAA's forecast on the Space Weather Enthusiast's dashboard. Here is now we're looking at the Earth here. This is the past 4 hours of Earth's magnetic moment from space. This depicts magnetohydrodynamic pressure, the units of which are nanopascals. And things are pretty chill here. The system is trying to reach static equilibrium, as it does with the incoming solar plasma. Next, Earth's magnetic moment from the ground for the past 4 hours. We show it daily on the channel. Those lit up areas are the most likely places to see the aurora. If you've got clear skies and low light pollution, break out your cameras and video equipment and see if you're able to capture the aurora there. At the moment, it's pretty unlikely in most places. Northern Canada may be seeing some. Also, northern Greenland. There's probably nobody there. Next, the planetary K index. KP2 is the current situation. It is a geomagnetically calm situation on planet Earth at the moment. Now let's talk a moment about Lagrangian points. The real-time solar wind is measured out here at Lagrangian point 1. That is a gravitational equilibrium point in between the Earth and the Sun, where low-mass objects like the spacecraft, the ACE, the Discoverer, the SOHO spacecraft, for example, are orbiting that gravitational equilibrium point. It just follows Earth around a slightly shorter orbit there, slightly closer. It's about 1 million miles from Earth to Lagrangian point 1. Just a reminder that the real-time solar wind has to be measured from outside Earth's magnetosphere. So here is that solar wind data. And again, we've seen the high-speed stream actually got a little higher here overnight. Now it's dropping back down toward nominal levels. So it's pretty unremarkable here for the past few hours. The coronal hole high-speed stream is subsiding, folks. Current situation is about 5 protons per cubic centimeter for the solar wind density. Solar wind velocity here just over 450 kilometers per second. And here are our GOES magnetometers. Now these are measured from inside Earth's magnetosphere. So the GOES satellites are located at an altitude of about 23,500 miles. And the N's and M's give you insight into where they're located. See these N's and M's up here? Those are telling you noon local time for the GOES 16, midnight local time for the GOES 18. So that tells you where they're located in their geosynchronous near equatorial orbits. Pretty unremarkable here for the GOES magnetometers as well. And let's take a look at the top view ecliptic plane field plot. Earth has just snapped into a North Pole current sheet. It looks like it'll be short-lived. A South Pole current sheet here likely to be showing up in, I'll say, about 30 hours. So I think on tomorrow's daily space weather video show, we should still expect to see a North Pole current sheet for Earth's magnetic field line. South Pole current sheet on the way sometime like mid to late day tomorrow on Sunday, August 20th. So that's the current situation. Let's move to our line of sight field plot. Solar B field depicted here in blue, North Polar field in green, South Polar field in red. Again, we've got like a year until we reach solar maximum, so expect lots of fireworks to come. The current week or so of a lull in solar activity is not going to continue, folks. We have been seeing a shortage of coronal holes. Let's look at those next from this fantastic National Solar Observatory data. There's our line of sight coronal hole plot. So we do have some North Pole coronal holes here hanging out around the southern hemisphere there, near the polar region actually. And let's take a look at coronal holes from SDO's perspective. So there is yesterday plus today from SDO. Let's zoom in a little bit on that. So we may see additional coronal hole high-speed streams associated with these coronal holes right in here. That'll take about 3 days, so sometime around midweek, Tuesday or Wednesday, we may see another intensification there. We have been seeing a shortage of coronal holes throughout this solar cycle, and there's a big uptick coming for coronal holes. So next we'll go to sunspots. And wow, what's going on? Let's see, this is NASA. Is NASA watching our videos? It looks like they're looking for an increased probability for solar flares in this group up here. I'm pretty sure I said earlier in the video that that's where we're expecting to see a large flare in the coming days. It is approaching the limb. It does have magnetic complexity, so all the features are there, folks, to see decent-sized solar flares there in the northwestern limb. Sweet. So there's the latest. Looking at currently a 26% chance. And let's take a look at sunspots from SDO. So there's a great equatorial zoom the past 24 hours there from the Solar Dynamics Observatory HMI instrument. Looking at the photosphere, which is what you could call the solar surface. Quite a few sunspots here. Just not a lot of flaring at the moment. Expect that to tick up in the coming 48 hours and the coming 12 hours indeed. And let's move to solar energetic particles and solar flares. So first, solar energetic particles, and we ain't got none. We've been flatlined here. So we saw the last event subside here days ago, like a week ago. And yeah, no new events there, no surprise there, as there have been no major solar flares, as you can see here. And the largest flare has occurred this morning. It was a short duration flare from that southwestern limb. It was about a C6. And let's take a look at it visually from SDO. So there's the past 24 hours. It was a very short duration flare. That double C-class flare event was from up here in the northwest. So while the largest flare was down here, really the most flaring overall was up here. And again, expect that to continue to uptick. Let's take a close look at this area down here. Again, it was a very short duration C6 class flare happening toward the end of that video. And we'll zoom in a little bit closer here. There's the full zoom. And next, let's take a moment to look up. So we put together this star chart here. This is for Lehigh Valley, Pennsylvania. If you want to make your own, skyandtelescope.org. Venus, now slowly becoming higher and higher in the morning sky here. Might be visible above the morning horizon there, the third brightest object in the sky. My favorite planet. Following Earth, I guess. Jupiter up there high on the ecliptic. Saturn has set a couple of hours ago. And if you want to view Mercury, you can now view Mercury after sunset if you've got a low horizon and low light pollution. As Mercury only gets so high in the sky, you can find it just to the west of Mars, actually, if you are looking for Mercury. Next, your solar system forecast. This is where things are today. We've got a crescent waxing moon at the moment. We'll advance this 1 week for your solar system viewing and forecasting pleasure. Engage. That's where things will be in 1 week. We will have a gibbous waxing moon by that point as we approach the August second full moon, because August 2023 is a blue moon month. Shout out to Nay for pointing that out on yesterday's live premiere. Next, you're invited to do citizen science. You don't need a degree or anything like that to do citizen science. Check out Galaxy Zoo at zooniverse.org, the world's largest citizen science project. We've classified hundreds of galaxies, and we're going to show you how that works right here. So the Galaxy Zoo features various different space missions, and one of them is to classify galaxies. AI is not smart. AI is not smart. It's absolutely asinine. AI is, let me get that right. AI is not smart enough to do this. However, you are. So just read the instructions, set yourself up a login here over at zooniverse.org, and check out the Galaxy Zoo project. So let's break this out here. Let's see. It looks like I see features. And it is looking like an edge on disk, wouldn't you say? Now, there is a slight brightening there, but I won't really say that's a bulge. I'll say no bulge. There is obviously a bright clump in the upper left, so we'll say bright clump. No disturbance. And it is, let's see, it is irregular. And that's about it. So it's an irregular, star-shaped, possibly edge-on galaxy there. And there you go. A galaxy has been classified. Again, zooniverse.org. Perhaps you'll classify that next galaxy before we do. And let's take a look at the fantastic. Check that one out. That's apod.nasa.gov, the astronomy picture of the day. And you may think you're looking at Saturn there. That's not Saturn at all. That is Neptune. So that's Neptune. And this is Neptune's moon Triton. Why is the moon so much brighter than the planet? Well, the reason is because Neptune's atmosphere absorbs a lot of infrared light, and Triton reflects a lot of infrared light, so that's why it is brighter. That's the James Webb Space Telescope, as you may have expected from the incredible resolution of that image. And then you can see these brightening regions. Those are clouds rising up really, really high in Neptune's atmosphere. So Neptune is what you would call an ice gas giant. Great view there. It's located about 30 astronomical units from the sun, so about 30 times farther away than Earth. And Triton is coated with frozen nitrogen, so that's part of the reason why it is so bright on that infrared imagery from the James Webb Space Telescope. Next, it's time to look at coronal mass ejections. We've got limited data here from the George Mason University. That's only 40 frames from yesterday, so let's skip ahead here to the Soho-Lascaux C2 and C3. Like we said earlier in the video, there is a large CME erupting from the eastern limb. As we make the video, you can see a great view of that there. And don't worry, we're going to show you even better views of that. There is also a pretty spectacular one out of the northwest earlier, late yesterday and early this morning. So let's take a look at stereo A here, since we figured out what the issues were with it. It had to change its orientation a bit to keep its high gain antenna oriented toward Earth. So here is stereo A's difference images. And yes, this is Nibiru back here. So that's Nibiru, no big deal. Nibiru is holding steady. It's not trying to create the apocalypse yet. Pardon my sarcasm and dry sense of humor. Sometimes people don't get it. Yeah, Nibiru there showing up on stereo A, folks. So yes, please make sure you share this if you're warning people about the imminent apocalypse caused by Nibiru or Elohim or Planet X or whatever is the current spooky thing in space. You're welcome. So that's stereo A's difference imagery. It's just using pixels subtracted from previous pixels, a running difference. And let's take a look at larger views here of Soho-Lascaux C2 and C3. That's pretty sweet. By the way, neither of those major CMEs, coronal mass ejections for the past 24 hours, are likely to strike Earth at all. They are oriented in vastly different directions than toward that blue marble. And make sure you leave us a comment if you're viewing the video from a different timeline, plane of existence, universe, multiverse, planet, galaxy, spaceship, solar system, etc. By the way, we've got some custom images as well. So before we talk about filaments, let's check those out. So here is a totally awesome 24-hour video there featuring Soho-Lascaux C3 in blue, C2 in red, and the SDO 193 angstroms wavelength. And we show that wavelength because if we do see limb darkening, it's an indication that a coronal mass ejection is headed toward Earth. 193 angstroms shows some great contrast when a large amount of plasma moves across the visible solar disk. It's a little bit tough to calculate coronal mass ejection trajectories at the moment, and that's part of the way we do it, by including that 193 angstroms imagery along with the coronagraphs. Here's a little closer view for you. And that CME that occurred most recently there in the east, that is slightly behind the eastern solar limb. Again, nowhere near directed toward Earth. And let's just show 193 angstroms by itself. And then we'll move on to look at filaments, because there are still lots of significant filaments, many of which are prominences, and many of which are overlapping the visible solar disk. So here is the El Teide, Spain ground-based hydrogen alpha imagery. And look at all those dark absorption features. By the way, this one here looks like it's becoming unstable. I don't think we've named that one yet. And by the way, we've been naming solar filaments after living people, sort of in the same way that meteorologists name storms, including winter storms nowadays. So let's continue naming filaments after living folks. Name them after your friends, your foes. Name them after yourself, if you like. And you can do that over on Twitter. And here's the grayscale imagery also, because this does show those prominences that we started the video out with. So some major prominences there, lots of major filaments. I'm not going to try to count them. But this one up here is definitely deserving of a name, as it's right in the Earth strike zone there, and it's starting to look unstable. So again, as far as social media goes, if you've unplugged entirely, we don't blame you, because the state of censorship is pathetic, disgusting, and indeed evil and un-American. So if you've unplugged entirely, we aren't surprised. However, if you want to actually interact on social media, that's the best place to do it. Hilarious conversations about Nibiru, chemtrails, geoengineering, HAARP, space weather, and serious ones about things as well, but for the most part, just a lot of lulls. So again, if you want to name filaments after living people, that's the place to do it, the only place to do it, not in the YouTube comments section. Follow the hashtag #NameThatFilament over there on Twitter, the platform that some people refer to as X, and which I refuse to refer to as X, because that's not a brand. You can't trademark a letter, folks. So here are the past couple of hours from the GOES 16 SUVI, and indeed you'll see that the final moments of that CME there in the eastern limb, a bunch of that plasma there splashing back down toward the chromosphere. That is the lowest layer of the solar atmosphere. From outward to inward, it goes corona, chromosphere, photosphere. Here we'll zoom out a little bit more there. It's going to show a little bit more detail. The cool thing about the GOES 16, folks, is that it has a wider field of view than the SDO. So while it doesn't show as much detail and resolution, it shows a greater extent of the solar corona. So it's a little bit more adept at showing those awesome prominences and CMEs as they happen. Next, we've got bonus features. We used to separate them, but it lowered our views on YouTube, so now they're in one long video. People seem to like long videos for whatever reason. So anyway, there's the satellite charging situation. It is minor surface charging there on satellites in the East Pacific at the moment. Just minor surface charging there, not likely to cause any significant communications errors. The GOES electron flux here is quite low. We are expecting an uptick on this in the coming days. The GOES electron flux is measured using radiography from the geosynchronous near equatorial orbits of the GOES 16 and GOES 18. It is measured at the F layer of the ionosphere, which we'll show you here in a minute. First, the 1-year graph of the electron flux. That's the greater than 2 mega electron volt electron fluence. You can see still at lower levels here. It will rise here shortly, following the subsiding of that coronal hole high-speed stream. And there you can see NOAA agrees. The forecasts are the green boxes. The observations are the yellow diamonds. Again, that's measured at the F layer of the ionosphere. Feel free to pause the video on this frame if you're not familiar with the temperatures of atmospheric layers, the penetration of electromagnetic radiation into atmospheric layers, and the chemical density of those atmospheric layers. We're looking at the F layer, which is one slice at about 300 kilometers of altitude. The F layer of the ionosphere, folks, the bridge between Earth and space. As we zoom in closer and closer to planet Earth, we're almost at our meteorology segment. So we're going to show some more features here. That's what's going on with the ionosphere. Vibrational frequency there depicted in megahertz, millions of vibrations per second. Here's the anomaly in megahertz from a 30-day median. High frequency anomalies shown in blue, low frequency anomalies shown in red. And not a lot of effects from that coronal hole high-speed stream. It was weak. It wasn't that fast. The density wave wasn't very high. So not a lot of major effects there resulting from that coronal hole high-speed stream. We'll show the latest image. Here is 1245 universal time ionogram and 1245 universal time anomalygram. We also show total electron content. It'll show you the most likely places for GPS errors when your GPS has to communicate through a lot of free electrons, it causes signal refraction. You could be off by thousands of miles if you have major GPS errors. And here is the coupled thermosphere, ionosphere, plasmasphere electrodynamics model. And things are looking pretty organized here. No major surprises showing up there in the total electron content forecast. We also like to show the North American anomaly now that we've showed the entire globe view. Again, as we zoom in closer and closer to the lower 48, there's the anomaly from the 10-day average over North America, and we are seeing continued signals here of high electron content anomalies depicted in red over Central America, the East Pacific, Mexico, the west coast of North America, etc. We'll let that play through one more time, and then we'll show the latest images from the SDO. So here's the refresh of that one. Here's the refresh of this one. So first, let's take a look at this sunspot. Again, it is the most likely place to produce solar flares. NASA and I agree, and when NASA and I agree, it's unlikely that either of us are incorrect. So that one's got some significant magnetic field complexity, as you can see there. And there are some deltas here. So we're seeing some tiny deltas here and some much larger deltas in this trailing region. So there you go. The most likely place for the next 3 days or so, 3 or 4 days from right up there. Let's take a look at the largest flare player over the past 24, which was this group down here. It's looking quite magnetically simple, actually. This one over here, it's very symmetrical. Hang on a minute. So there's that one. There is a little bit of delta there. Some small deltas there in between. Here's the full disk rock back because it's time to get to meteorology. However, before we do that, we've got various paid affiliate sponsor links that you can find in the description below this video. They're also on our homepage at smashomash.com, and one of them is the Hemp Lucid link, so check that out if you're in the market for CBDs, mushroom gummies, body balms, THC-free products, Delta 8s, and lots more. So check that out. Help keep the channel in existence, as we're paid just to the side of nothing by YouTube to put the content on YouTube. So help out the channel this way. We need your assistance. So yeah, one of those ways is through the Hemp Lucid shop. It is one of our newest paid affiliate / sponsors. Great deals there. Another way to help the channel out is by shopping at our Amazon shop. It's amazon.com/shop/smashomash. You may find a bunch of supplements in there. For example, if you're not familiar with L-lysine, it's an essential amino acid that is required for the production of hormones, enzymes, and antibodies. And in the past 3 years, you may understand the importance of hormones, enzymes, and antibodies. Again, essential amino acids must be taken in through diet. They cannot be produced endogenously, meaning in the body. They must be taken in exogenously through food or supplements. So ensure that you're getting your lysine. Next time you feel like you're catching a cold or something like that, perhaps pop some L-lysines. I like the 500 milligram choice, and sometimes I'll go on like 1,000 milligrams in the morning and 1,000 milligrams at night if I'm feeling like I'm really going to get sick. And by the way, I almost never get sick, so I'm not making any sort of medical claims here. However, I am telling you that I've been taking L-lysine for a long time, and I don't get sick really very often at all. Also, you can help out the channel by picking up merch. So one of the ways you can do that is by helping us advertise. You can save 30% site-wide. Maybe pick up some The Smash News Network, least busted name and news products. Everything from tote bags to comforters. Yeah, I can speak English. Postcards, metal prints to hang on your wall, transparent stickers. It's got the YouTube URL there. Again, thanks to our new subscribers. In all seriousness, thanks to everybody who leaves comments every day. We do appreciate that. Again, save 30% site-wide on the Redbubble shop. And once again, thanks for tuning into the Smash News Network, least busted name in news. Facts, they're very controversial in the year 2023, so help us get them out there by going out in the public and wearing the Smash News Network right proudly on your whatever products. Cheers. Links below the video as well as on the homepage at smashomash.com. So welcome to the Neo Renaissance. We built a massive web ring to benefit people like you. So use it to your advantage. If you want to host things on our forum, you can put your memes, put your recipes. There's even a dream log there. There's a cosmology forum. There's a Earth and Geophysics forum. There's a heliophysics forum. Smashomash.com/forum. You can read about our mission there. You can read about our forming.org organization over there. The best way to support the channel from a financial perspective is to become a gold annual paid-up subscriber. It's almost like getting 4 months free of a gold membership. It includes complimentary merch. Smashomash.com/Smash Team. Once again, thanks to the Gold and Silver Smash Team members for increasing the possibility that these videos will remain publicly visible, free for all to view, and existent. It's almost like Patreon, just way better, as it has much higher capabilities. We even send out email alerts for videos just like this one. That's the Twitch stream, by the way, right there at smashomash.com/Smash Team. So moving to meteorology, I suppose it'll probably be pretty popular today. And unfortunately, I suspect most people are unable to forecast their own weather, but it's really not that hard, folks, as you've got all the data that you need. If you understand the physics and you've got the data there, you are good to go. Here is Hillary. So we're showing 81 mile per hour winds there and nearly 45-foot waves. It is some high surf there at Baja California. You can certainly expect some beach erosion, as that thing is like Baja California. What is the maximum altitude there? Like 20 feet above sea level or something? It's a giant sandbar. So yeah, it's that's going to be some damage happening there for sure. And this is going to be mostly a rain event by the time it strikes the U.S. At the moment, it's still a major hurricane. So major waves there, the biggest waves in the world, 45-footers there off the east side of Hillary. That is showing wave height and winds. So there's just a surface wind map. We're going to zoom out and show the whole planet view. There are the surface winds of the east. Here are the jet streams of the east. Strong anticyclone here over Asia. You see that clockwise rotation, likely clear skies over that area. Here are the jet streams of the central world. The surface winds of Europe, Africa, and Central Asia. And surface winds of the west, followed by the jet streams. That's what's going on. And moving on, here's our windy.com map. And we're actually showing wind here. And we're going to show a forecast here. As this makes landfall, it's going to brush along Baja California and start to weaken. So this is the Euro forecast. It's already weakening there as the eastern portion of it strikes Baja California. No real surprise there. That's where things are expected to be in 24 hours. You can see a significant weakening there of that system over the next 24 hours. This is the GFS model. Just keep in mind that there is still a lot of moisture, and it's got to go somewhere, and it's going to be going to the southwestern U.S. So here's a close-up of it. That's the shortwave radiation map, part of the NASA GOES Interactive Weather Satellite Suite. Still a pretty well-defined eye wall, but it's getting a little bit irregular in shape there as the clouds to its east vastly exceed the clouds to its west, which is no help to North America, as it's going to be dropping quite a bit of rain, which we will show here in a moment. First, we'll show the full disk view. Here is clouds and fog over the Americas. And shout out to our viewers from all around the world. We're delighted to have made so many friends and foes and neutrals throughout the making of these videos. Don't forget to love people you dislike, folks. Love those that you dislike. That's a real challenge. So here is our weather.gov map, the National Weather Service homepage. And look at all that flooding in the western U.S. Pay attention to that. Also, hurricane and tropical storm warnings there around the west coast. What the heck? All right, so there's the key. Weather.gov is where to go to get your weather warnings. High temperature warnings there in the central U.S. We'll show some forecasts next. Here is your pressure and precipitation forecast for the next 72 hours. You can see the pressure rising significantly there, over 1,000 millibars, as that makes landfall right at the northwesternmost point of Mexico there, and then moving almost due north. Not an optimal storm track there as far as flooding in the western U.S. So here's the total accumulated precipitation forecast in inches. And this actually looks much worse than it did yesterday, because we're seeing over 5 inches of rain there for large portions of both California and Nevada. The storm track has moved a little bit to the west, and that is suboptimal. Again, that's a GFS 72-hour total accumulated precipitation forecast in inches. We'll also show the jet stream forecast, and that's part of the reason why that storm is able to move that way. It is basically following the jet stream. So when you have high pressure winds, they're going to create a low pressure system behind them as the atmosphere tries to reach static equilibrium, and that's what's going on. Normally the jet stream is going to move a system from west to east, but at the moment, not so much. So the jet stream is largely in control of weather patterns, and look at the intensification of it up there over central Canada. Major jet stream intensification happening there. It's going to be blasting some very cold air down to Maine in about 3 days. Last but not least, here is the temperature anomaly forecast in degrees Celsius, and you're seeing all those cold temperatures showing up there in the west. That is a result of high cloud cover and massive rains. Central part of the U.S. there, well above average there, seeing some areas where you'll see about 12 to 15 degrees Celsius above normal. Again, that's a 72-hour GFS temperature anomaly forecast in Celsius degrees. Here's lightning over the past about 10 hours. And of course, somebody's going to say, look, directed energy weapons north of Cuba. It's the U.S. Navy firing directed energy weapons into the ocean for no reason. Remember, folks, extraordinary claims require extraordinary evidence. If your theory is idiotic, it's... Oh, directed energy weapons. They've been around for decades, since the 1970s, widely known about since the 1980s. And people just found out about them 5 minutes ago, and now they must be used because there's motive, means, and opportunity, except for the motive. So there's your current lightning map there from lightningmaps.org. Highly recommended when you hear thunder. And we do have some terrestrial strikes here already happening around the U.S.-Mexico border there. Check it out. Strong cell there. Southwest of the Barry Goldwater Air Force Range, which of course is directed energy weapons, or maybe it's HARP, or maybe it's geoengineering, or maybe it's chemtrails, which, by the way, chemtrails are not a thing. Planes creating contrails in the troposphere are not geoengineering or anything more than a demonstration of the humidity in the atmosphere. Moving right along, to close this mother out, here's the U.S. Doppler radar map. And already some rains there showing up in California and Arizona. There's a lower 48. Here is clouds and fog. And there is water vapor. And there is a lot of water vapor. And there's going to be more and more in the coming days. So there's still a lot of convective energy there in all this warm water in the Gulf of California here. Also, on the other side of Baja California, there's still like 83-degree water out there, so there's still a lot of convective potential to continue to pull moisture into the atmosphere. Here's your recap to close this thing out. Vertical motion in the air column, detected by ground-based systems known as Doppler radar. Space-based systems here depicting 3.9 micrometer infrared radiation. It shows clouds and fog even at nighttime. And there is your water vapor map. It shows all the water vapor as this low-pressure system here loiters over northern New York. Anyway, it's time to close this thing out. Thanks for tuning into the Smash News Network, Least Busted Name in News. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.